Okay, for example 5, this is where you're going to have your two solutions case. And you really don't know you're going to have two solutions except for the fact that we're going to know that your A value, the length of A, is between your length of your B and the length of your height. And your height is going to end up being this length right here. And when you want to find out what your height is, well, your height is just equal to your B times the sine of A. So we'll get to that here in a moment. But when you first solve this problem, you know you're going to need to find angle B. You're also going to need to find angle C and side C. So here are the three things we're looking for. So the first thing we can solve for is going to be angle B. So we may not know that we have our two solution case yet. So if we solve for angle B, then what you're going to do is you're going to take the sine of B over side B, which is going to be 5, and that is equal to the sine of A, which is 58 degrees, over 4.5. So when you solve for this, you get the sine of B is equal to a 0.9423, and when you take the arc sine of both sides, so take the arc sine of the left, take the arc sine of the right, you're going to end up and get that B is equal to 70 degrees. Now your calculator is only going to give you your acute angle. So what you have to know is that this is going to be one of your options, and your second option is going to end up being that B, your second angle, possible angle, is going to end up being whatever 180 minus 7 degrees is, which is going to be 110. So if we take, the reason we know we're going to need two values is, number one, because H, or A, is less than B. We know that because that's given here in our problem. So if we know that is less than B, we have actually only one option, that you're going to have two solutions. Now you also find out that this is greater than H by plugging in your formula here. H equals B times sine of A. And you're going to get this formula from your book. If you go to page 406, you find out that you get two solutions here if A is in between your height, which is really your altitude, and if it's greater than your height and less than your B. So if you use this fact right here, the H is equal to your B times your sine of A, for this problem right here, you're going to find out that your H is equal to your B, which is 5, times the sine of A, and your A is 58 degrees. So when you plug this into your calculator, you find out that 5 times the sine of 58 is equal to a 4.24. So that obviously means that for this problem, your H is a 4.24. Let me get the right color here. 4.24. Your A is a 4.5, which is less than your B, which is 5. So you're going to have two solutions here. You're going to have two different cases. You're going to have one where your angle B is equal to 70 degrees, and then you're going to have another one where your angle is going to be equal to 110. So we're going to solve both of these. So for case 1, where your angle B is acute, that means this is where you have your 70-degree angle. So if we want to solve for your angle B, which we have, we still need to find out what angle C is, and we're calling it called a sub 1, B sub 1, and we're also going to need to find out what side C is. So this is going to be side C sub 1. So if angle B is 70 degrees, then to find out what your angle C is, we're going to take angle C, we're going to take 180 minus angle A and angle B. So we're going to say 58 degrees plus 70. This ends up and gives you a total of 180 minus 128, which gives you an angle of 52 degrees. So here is one possible, well, this is your possible angle for C when B is equal to 70 degrees. So now the last thing you have to do is you have to figure out what your side C is. So side C, you can just use your law of sines. Say C over the sine of C, which is 52 degrees. That's going to equal to, I'm just going to use side A and angle A because that remains constant no matter what. So I'll say 4.5 over the sine of 58 degrees. And when you solve this, you find out that C ends up equaling 4.2. So your side C gives you 4.2. So for case 1, angle B sub 1 is 70 degrees, angle C is 52, and side C is 4.2. And it should make sense that your sides, remember, your bigger angle is going to be across from your bigger side. So 70 is across from 5, 58 is bigger than 52, so 4.5 is bigger than that. And then your C, which is 52 degrees, would be across from your smallest side. So let's look at case 2 here, where angle B is going to end up being 110 degrees. So this is our B2, and we need to find all of our values. So we have angle B, we have angle C, and these are actually sub 2s, because this is our second case, and then you're going to have side C, sub 2. So if B sub 2 is 110 degrees, we can say that we can find our side C. So we're going to find side C, or angle C, sorry. Angle C by taking the sine of C sub 2, or side C, which we don't know yet. I'm doing this one wrong. Sorry, back up. Alright, here's how you find side. Angle C. Angle C is found by taking 180 minus 58 degrees plus 110. This gives you a 180 minus a 168, which gives us a 12 degrees. So angle C is only 12 degrees in this case too here. Now, to find side C, you take C over the sine of 12 degrees, and we're going to set that equal to A over sine of A, so we're going to say 4.5 over the sine of A, which is 58. So when we solve for this, you find out that C sub 2 ends up and equals a 1.1. So here are your answers for case 2. So remember, the biggest thing you have to remember to look for when you're trying to figure out if you have to use this case is you have to make sure that A is less than B first off, and if it is, then you need to check and see if it is going to be greater than H. So that is the key to finding your two solutions for the ambiguous case.